the lines?
The 4 lines that say this
Sure.
way.
Yeah, they don't really matter for this hour because I'm pretty sure I'm one of the only people that teaches at this building this hour. Most of them are English teachers in their first hour playing.
All of them, but I was just across the hall. I didn't want to go around.
Almost for almost all of them, except my last hour because like that's right next to the door. But if I call it, I have to go all the way around.
Around the building.
Sure.
Let's see.
I wonder if they'll try to enforce those more once everyone is back in one group. Got more people. Yeah, that's pretty good. Barbecue sub. And judged some Congress for forensics. Oh, yeah? Oh, yeah? That's pretty good. That should do.
Yeah, that should be good.
That should do. Did you know that in Roman numerals, you can only ever place 1 before a 4 or 5? So to write 49, you have to write 41 minus 10.
Yeah, probably.
You know, that is kind of lame, but it's I'll let it slide. So, gosh, it's so tiny. Mhm. All right. So for bell work today is actually a pretty hard problem. Nope, this one. You need to verify that the secant plus tangent of x is equal to cosine over 1 minus sine. So to start with this one, I would always start with the more complicated side. which looks like it's the right side, and I will give you the first step. The first thing you will want to do is multiply this fraction by its conjugate. 1 plus sine of x to the numerator and the denominator. That's the first thing you need to do. I'll give you 3 minutes. Well, I mean, there are a lot of different ways you can do this problem. But that's how I'm going to go over it. So if you want to be consistent, I suppose. If you find a different way, that's fine too. I'll give you 3 minutes to see how far you can get, and then we'll go over it together. All right. So if you multiply these together, you should get distribute the cosine, and the numerator cosine plus cosine sine. And in the denominator, since you're multiplying something by its conjugate, remember you could just square each term. So 1 squared is 1, sine squared is sine squared, and then write their difference. If you did remember that shortcut, remember you can also get the answer by double distributing. 1 times 1 is 1. 1 times positive sine is positive sine. But negative sine times 1 is negative sine. So then the positive and the negative cancel out, which is why there's no middle term. And then negative sine times sine is negative sine squared. All right, Does anyone have an idea of what I should do next or what I could do next? Yeah, that is a trig function squared. Whenever you see a trig function squared, you need to use a Pythagorean identity. And the one that sine is in is sine squared plus cosine squared is 1. Which actually almost looks exactly like our denominator if we just subtract the sine to the other side. So then what I can do is instead of writing this, I can write cosine squared. You know, those people that say, hey, I, started disliking math once they started introducing letters. What about when it's only letters?
Yeah.
Dude,
I'm not a big fan.
isn't that great? Yeah. All right. What do you notice about this? What else can we do?
If you add those two
Ye-
together,
That's right. Yeah, you can factor out the cosine and cancel out. So functionally, every term is losing a cosine. So then I'll get 1 plus sine over cosine. I notice that my answer is supposed to be 2 terms, right? This plus that, and it's 1 term right now. But if I split this, I think we're ready to get this problem finished. I don't know what the best term for this step is. And you can probably put either one of those, separate or. All right. What is 1 over cosine really? That's secant. That's your reciprocal identity. What is sine over cosine really? That's tangent. That's your quotient identity. Happy day. We got to where we needed to go. All right. I think it's a pretty hard problem. So I think if that makes sense to you, you've probably mastered 5.2. Today, we're switching gears. We're going to do start 5.3. And really for the rest of this chapter, I think will be less about, solving and writing, or sorry, verifying and that kind of stuff, but we still will do some of that. But I think we're going to put a little bit more emphasis now on I say that, I might be lying to you. Nope, it's still pretty much a mix, half and half. But today, at least, today will be an easier day because we're going to just focus on solving these trig equations, which is just using your algebra skills. All right, so before we go into that, does anyone need more time to write or any questions about the bell work? Okay. So we're going to start solving trig equations using algebra. So for example, let's say we have the equation 2 sine of x minus 1 equals 0. Our goal is to solve that for x. These problems that we're going to do are not too bad. The only catch that you'll have is really forgetting to do steps. So if you're careful and you do all your steps, I think you'll do just fine on this. But the most likely thing that's going to happen is you're going to only give me one answer instead of finding all the possible answers you're supposed to. All right, so if I wanted to solve this for x, what do you think the first thing I should do is? Add the 1 to the other side. 2 sine of x equals 1. 2 more steps. Divide by 2. Okay, this one sometimes catches people. How do you get rid of the sine? So happens to taking the sine of x. Inverse. Okay, here's the catch. You have solved problems like this, though maybe not. I think probably even simpler than this. Back in honors geometry, and then you get to this step, and then you would reach for your calculator. Is not what we're going to do. That is what's going to get you in trouble in here. Ideally, what we're going to do is reach for our unit circle, because then you'll find all the answers. We'll go ahead and do this degree and radians. So let's do the degree first. So if you did this in your calculator in degrees, it would tell you that the answer is 30 degrees. And that is one answer, but there's a lot more. If you look at the unit circle, remember the sine of an angle tells you the y value on the unit circle. So where on the unit circle do we have y values of a half? Again, we got it here at 30 degrees, but also here at 150 degrees. So that is also a solution. The sine of 150 degrees is a half. But you're not done yet. I'm trying to find all the values of x that satisfy this equation. And those are not the only numbers. Anytime my angle ends at this point or this point, it will be a solution, which means that this angle is also a solution, where we go all the way around the circle and then stop there, which would be 390 degrees. So that's another solution that we have to write. I could do that again. So I could go around the circle twice and then end there, which would be 750 degrees. That's another solution. Similarly, I could do the same thing for 150. I could write negative 210 degrees. That also stops at that point. Or, I could go positive 410 degrees. That also stops at that point. So there's an infinite number of solutions that will end at having a y value of a half. So how we will write those is not hard. You just have to remember that you're supposed to do this and the notation that you use. So the general solution then is x is equal to 30 degrees plus 360 degrees times n, and 150 degrees plus 360 degrees times n, where n, where n is an integer. The Z double stroke stands for integer. The E little e, I think that's lowercase sigma, stands for is in the set of, which you can usually just abbreviate to is, and is one of the integers. So this lets me represent all the possible infinite solutions for like when n is 0, when we don't add 360, or when we add 360 once, twice, negative once, negative twice, so on and so forth. If we did this problem in radians, same steps, but instead of pulling the angles, we would have pulled the radian term, the pi, and we would have gotten, or in radians, pi over 6 plus 2 pi n and 5 pi over 6 plus 2 pi n. So again, the only real difference there is instead of doing 360 degrees for one revolution, there's 2 pi radians in every revolution. All right, so ideally, this is how you'll do the homework, quiz, and test problems. It's by hand, like this, using your unit circle. But if I have lost you at any point in the last 5 to 10 minutes or so, there is an easier way to get this answer super quick, and that's just to use a calculator. So I'll show you how to do it in the TI-84 and in Desmos. To do that, I'm going to clear this. Does anyone need more time to write? Okay. Ooh, share. Whole screen. Nope, whole screen. Good. All right, TI-84. If you hit y equals and you type in your equations, to the left side as one equation and the right side as the other, you can then get your answer in radians by hitting graph. Oh gosh, hold on, window, zoom, sorry, 6. There we go. And you can see wherever these two intersect is a solution, and you can get those points by hitting second trace, intersect. And then you can move your cursor to where you think an intersection point happens. It'll tell you. Now, the problem is it'll tell you the answer is a decimal. So usually what I'll do then is I won't, if I want to find my answer in radians, I'll actually set my calculator to degree mode. Change the window so it goes from like -310 to 370. And then second trace, pulls up my calculate window, go down to intersect, move this over to where they cross. And that'll give you the answer in degrees, which will usually be an exact answer. And then I'll just convert that to radians. Multiply by pi, divide by 180. And if you need the answer in degrees, then there you go, you got it. And the very first two times, the solutions you have between 0 and 360, right, will find all the solutions for you. And then next to each answer, you just put plus 360n, plus 360n, plus 360n. Okay, so that's how to use the TI-84. And if you're prepping for the ACT or whatever, that's probably something that you want to practice using. But for my homework quiz and test, you can't do this in Desmos. Same thing. You're going to type in your two equations, 2 sine of x minus 1 and 0. Oh, sorry. Y equals. There you go. And again, the nice thing about that one is when you click on it, it'll give you the answer, right, correctly. And if you need it in degrees, then again, you just change it in degrees, but you'll have to change the window to match also. Yay? So ultimately, again, it would be nice if you follow the enhanced step, solve this for x properly, use your unit circle to find your values. But when push comes to shove, if you get lost, you just type it into Desmos, you'll get the answer in 30 seconds. Yay? All right, then let's have you try one. So I want you to solve this equation again, first try to do it by hand, but if after a minute and a half, 2 minutes, you're stuck, you don't know what to do, at least then go to the calculator and do it there. That way you can leave class with at least one method of finding these answers. Minute left. Okay, it looks like we did better than the morning group. Everyone made it, or instead of tried, to the sine inverse of -1. All right, so yeah, to solve this, subtract 1, sine of x equals -1, sine inverse. And then remember, once you're here, you can find that either using the unit circle or with your Desmos or with your TI-84. If you think when is y -1, you should think that's the lowest part on the graph, right? Which would happen at 270 degrees. And then again, you just tack on to the end, plus 360n. Or if you did it in radians, 3 pi over 2 plus 2 pi n. Again, because that's on the unit circle. Right. Yay. Okay. Let's try a harder one then. What about this one? Solve the sine of x plus the square root of 2 is equal to the negative sine of x. Nice thing, we only have to find solutions between 0 to 2 pi. So at the end, what you get for your answer is your answer. You don't have to write plus 2 pi n. All right, Just like in algebra, you're going to start this problem just like you would in algebra 1. Whenever you have an equation in algebra 1 with x's on both sides, the first thing you would do is get all your x's on one side. So the first thing I'm going to do is move this negative sign of x to the other side by adding. Gives us 2 sine of x plus the square root of 2 is equal to 0. And now this is just like the last 2 problems we've done. I need to solve this for x. It's going to be 3 steps. First step, get rid of the square root of 2 by subtracting. Next, we get rid of the 2 by division. Last, we take the inverse. And then I think about my unit circle and be like, well, square root of 2 over 2's, that's the ratio for a special right triangle. That's 45, 45, 90. So those are all the quarter angles, 45, 135, 215, and 315. Is that right? 305, 315. No, 315. Because our sine inverse is taking a negative number, we know it's going to happen below the x-axis, which means it's in quadrant 3 and 4, which means it's 270 degrees and 315. Or sorry, 215 and 315. And by 215, I definitely meant 225. But also, we do have to use radians in this one, since they gave us the intervals of 0 to 2 pi. So the answers are 5 pi over 4 and 7 pi over 4. Okay, if I was going to verify this in my calculator, again, I'm going to type the left side of the equation as one of my equations. And then I will type the other side, the right side, as my other equation. And then, oh, I need to change this back to radians. And then I will look for where they intersect. Yay? You see, you get the same answers that we got. Also, isn't that kind of pretty? It's kind of cool. I will say this class is probably one of the prettiest math classes we'll do. Once we get into non-Cartesian ones and start doing stuff in polar coordinates, those graphs are really cool. We'll make like roses and that kind of stuff. It's pretty cool. Oh, hold on, before I erase it. Any questions about this? Anyone need more time to write? Okay. Let's try another one. Even harder now. Look at this one. This is a spooky problem. If I put this on a quiz, I'm fairly certain only like 5 to 10% of you are getting this right. This one has a lot of parts that can mess you up. And it kind of lulls you into it too. You feel like you're doing it correctly. And the answer you get will work, but you're going to be missing a whole bunch of answers. All right, add 1, both sides. 3 tangent squared x equals 1. Divide by 3. Tangent squared equals 1/3. Okay, here's the first hurdle. Now, this is really the make or break it. How do I get rid of the squared? Square root. Okay, That's wrong. You just lost half of our answers with the way I have this written right now. We will get rid of the tangent. You're right. That is the next step. But I have messed up this step.
You dropped this one.
I did drop the squared. And when you solve an equation by square rooting, you have to, there's a little thing that has to be added right here in front of the square root. Plus or minus.
Oh, yeah.
Right, and if you think of it like imagine that this was the number 9, right? If I square root 9, 3 is an answer, but -3 is also an answer, right? Because -3 squared is 9. This right here is what costs so many people points on this. You have to put the plus or minus, otherwise you just lost half your answers. Then we do the tangent inverse. So we're going to do the tangent inverse of the positive. Okay, actually, before I do that really quick, this is the same thing as plus or minus 1 over the square root of 3, which is the same thing as plus or minus square root of 3 over 3, which is really the best way to write it because then you don't have a radical in the denominator. Okay, anywho, I'm going to do the tangent inverse of positive square root of 3 over 3 and the tangent inverse of negative square root of 3 over 3. And to find those on the unit circle is kind of tough because remember tangent is y over x. And in the unit circle, you would have to actually like go ahead and divide these to get that. Now you do know the square root of 3 is supposed to end up on top, or actually that's not true. Square root of 3 is actually going to end up in the denominator. So there is a way to pull that from here, but to be honest, it's a lot easier if you just use a tangent unit circle where it has those ratios already done for you. And so you could see that the square root of 3 over 3 happens at 30 degrees and 210 degrees. And so you do plus 360n plus 360n. And the negative square root of 3 happens at 330 and 150. So you'd have 4 answers, each with plus 360n. But also not really. Because there's an easier way to write that set of numbers than to write all 4 of them. Because remember, the period of tangent is not 2 pi or 360 degrees. The period of tangent is 1 pi. So the easiest way to write this answer is actually just to pick 2. The answers in either, I always use the first and second quadrant. I think a lot of people also use the first and fourth instead. It's the same. The answers in the second and the fourth quadrant are the same. So it doesn't really matter, right? But okay, I'm going to do the first and second. So my answers then would be x is 30 degrees plus 180n. Because again, tangent and cotangent only have a period of 180 and 150 plus 180n. Or in radians, that would be pi over 6 plus pi n and 5 pi over 6 plus pi n. Okay, that was a pretty evil problem. At the end of this, though, we know we can get those answers, and we know we can get those answers in 30 seconds. All we gotta do, go to Desmos, type in 3 tangent squared x minus 1, y equals 0, Those are your answers plus pi n again. If you kept going and did these and put plus 2 pi n, like all 4 of them, and put plus 2 pi n next to each one, that's fine. You just have said one of the answers multiple times. That's not actually true. You have just written the answer in more characters than you need to. Right? It's the same thing, but that's the part where RubberSign actually draws you back, because on a normal piece of paper, you can write that big thing and be like, yes, that's right. It's just telling me more than I need to know. But a WebAssign, they would probably only have 2 spaces rather than 4. Well, I guess that's a hint to you, though. I mean, that's a pretty strong hint. When you find your prayer answers and only see there's 2, then you'll be like, oh, yeah, those are duplicates. Oh, yeah, it's tangent. That's the weird one. All right, questions about this one? Okay, there's one more technique I want to show you before you leave. We won't finish this problem. I just want to start it. Look at this example. Cotangent cosine squared equals 2 cotangent. All right, if I wanted to solve this for x, again, first thing I want to do is get all the x's to one side. And then you could get stuck looking at this and be like, what am I supposed to do next? Well, notice that each of these terms has a cotangent x. So I could factor that out. And now that I have this factored, you could solve it just like the other examples if you separate the factors into 2 different equations. So this equation, values of x will satisfy this equation if we can make the cotangent of x equals 0, or if we can make the cosine squared x minus 2 equals 0. And then this is like the previous examples where, you know, I'm going to take the inverse and look, where is cotangent 0? Well, cotangent is x over y, so it's 0 whenever x is 0. Add to square root, don't forget the plus or minus. And we're looking on the unit circle for the square root of 2. And then you'll get your list of answers, which actually, for this one, it's no solution. Because it's impossible for cosine to equal the square root of 2. That's 1.4, which is outside of the range of -1 to 1. But anyway, you could read through this example step by step if you need it to finish. I have it in the lecture notes and all that. But ultimately, at the end of the day, if you see this and have no idea how to do it by hand, you can do a calculator in 30 seconds. Yay? All right. I feel pretty good about this one. I think this is the lecture I'm going to save and use for my other classes.